So back in number 30, after looking at it a little bit, this is on the January 2018 exam. What I'm going to look at is if we map t over the line y equals negative x as a line reflection over y equals negative x, t maps to c, r maps to a. That's great, right? The problem is s will map over to here. So that'd be s prime. So I thought, okay, maybe there's a rotation involved or something like that, but here's what we also know. If we can fix orientation, get two figures that have the same orientation, and we map 2 points, okay, we match two pairs of corresponding points, that and orientation, that should lead to all 3 vertices being in the same location. If it doesn't, triangles aren't congruent. Okay, so that's what I'm going to go with. That's what we learned a long time ago, back when we looked at rigid motion transformations. It's been a long time, though, since we've had to apply it. So here's what I'm going to do. First, I'm going to say the answer is no to this. Okay? Triangle ABC is not congruent to triangle RST. Because there is no sequence of rigid motion transformations that will map triangle RST onto triangle ABC. Now, that's the explanation. How do I prove that there isn't one? I'm going to have to, now this is only a 2-point question, so I don't believe it's supposed to be too involved, but I want to make sure I'm thorough here. Okay, so I'll do this. If we reflect triangle RST over the line y equals x, I'm sorry, y equals negative x, and then actually, you know, if you can show some of this work, it's great. So that's a line y equals negative x. R prime is negative 9, 2. Same location as A. T prime is going to be 1, 2, 3, negative 2. Negative 3, negative 2. Sorry, negative 3, negative 2. Same location as C. Okay, now, problem is S prime will land at 1, 2, 3, 4, 5, 6. Land at negative 6, negative 5, which is not the same location as point B. Now this is a little bit more advanced, but probably we wouldn't need to do any further. That's pretty good. So a triangle R prime, T prime, S prime has the same orientation. That's arrangement of letters as triangle ABC and two pairs of corresponding points are at the same location. So if the triangles were congruent, all 3 points should say pairs of points would be at the same location. But they are not. Now, I know I way overdid it on that, over-explained, but I wanted to make sure that it was clear to everybody why. There is actually this concept. If you have the same orientation and two pairs of corresponding points at the same location, the figures would be congruent at that point, as long as all the rest of the points were matched. Okay? That didn't happen, so they're not the same. All right, moving on. Another 2-point question, last one. Bob places an 18-foot ladder 6 feet from the base of the house. Okay. So you assume the house and the ground have a right angle between them. The ladder is leaning. This is 18 feet. This is 6 feet from the base. Okay, that's the bottom of the ladder. This is where it's leaning against the house. Okay. So they want to know this angle right here. So we call that, I always call that theta. If they call it x degrees, whatever, that's fine. Okay, so what we're after is we're after the angle measure. Okay, in this case, we're going to say it's theta. Now, relative to this theta, this leg is opposite, this leg is adjacent, and this leg is the hypotenuse. So for me, if I was using my acronym, right, sine, cosine, tangent, I would use cosine, because adjacent hypotenuse. Okay? So adjacent hypotenuse, cosine of theta equals adjacent over hypotenuse. Now, this is a different mechanics than our typical find the length of a missing side. Okay? We're trying to find a missing angle, so we're going to be using inverse trigonometry right now. All right. So let's type in we don't know the angle that's missing, right? So just keep rewriting it until we have something to fill in. Now, adjacent is 6, hypotenuse is 18. Personally, for me, I change that into a decimal, 4 places. It's 0.3 repeating. Now, this is where the mechanics of it gets a little tricky. It's hard to understand for students. If we knew the angle, the cosine function would give us the ratio of the two sides, adjacent to hypotenuse, that we could expect. When we don't know the angle, what we have is the ratio of the two sides, adjacent to hypotenuse. The ratio of the sides is 0.3333 to 1. Okay? So what we can do is we can use inverse cos to figure out what angle would have that relationship between the two sides. So we perform this operation. To get rid of cosine, we should perform cosine inverse. Okay. Now, if we do that to the left side to knock out cos, we should do it to the right side to keep the balance. So type in cos inverse of that 0.3 repeating. And what I get when I do that, remember, cos inverse and cos knock each other out because they're inverse functions. Okay. Now it's cos inverse of this decimal is 70.528. And what are they looking for here? To the nearest degree, Yeah. So I got to go 71 degrees. Okay, that's it for the part 2's, which are 2 points each. This is our first part 3. Okay, so we should expect a little bit more involved here. So part 3, those are worth 4 points each. So we should make sure that we have a little more work going on. All right, describe a transformation that maps triangle ABC onto triangle ADE. There's definitely going to be more. Okay, explain. That's going to be down there. Okay. So it's going to be a dilation centered at point A. Why? If D is the image of B, right, they all have to be collinear. E is the image of C, they have to be collinear. What I'm going to do is I'm going to go get the scale factor, and really, I don't need to do everything. I don't need to calculate any sides. Here's really what you could base it on. You could just base it on the change in X. So the change in X for A to C, right? That's 1, 2, 3, 4. The change in X for A to E, and all we need is a change in X. 1, 2, 3, 4, 5, 6. I got 12. Okay. Now, E is the image. The image is bigger, so it got further away. If you're ever wondering about how to get the scale factor, just think, is it an enlargement or a reduction? And then you can create two fractions. It's either 4 out of 12 or 12 over 4. Now, the reason it's this one is because it's an enlargement. The image is bigger. Okay, so the number needs to be bigger than 1. All right, so the scale factor will be 12/4. All right, now here's what we're going to do then. Describe the transformation. So we're going to dilate triangle ABC centered at, well, when this could be dangerous, make sure we give a location. I always want to be careful of that. I got 9, negative 9, negative 8. At A, which is the point negative 9, negative 8. Okay? That's our center. You have to have the center. It doesn't count by a scale factor of, you could reduce it to 3. Okay? You could keep it 12/4. You could go to 3. All right, good enough. Explain why this transformation makes triangle ABC similar to triangle ADE similar to triangle ABC. Okay. Triangle ADE is similar to triangle ABC because there is a sequence of similarity transformations that maps triangle ABC onto triangle ADE. And that's it. Okay, number 33, we'll also do on this one. So we got to remember this one is worth 4 points. Okay, there's a reason for that. What you have is a half sphere. You got to recognize that this is a half sphere on top. Now the volume formula for a full sphere is 4/3 pi r cubed. All right, so we could multiply that by a half. Let's use 2/3 pi r cubed for a half sphere. Now you can do it this way. You could calculate a full sphere and then cut it in half at the end, or you could just manipulate the formula early. It doesn't matter to me. Okay. Now, how do we get the radius? Well, the radius is half the diameter. So if the diameter is 8, the radius is 4. So R equals 4 meters. So let's go get that volume. And be careful, you got to use that button on your calculator to get to the third power, unless you know another way. All right, the volume I'm getting out of my calculator is 134.04 just for the top half sphere. Okay, top part. All right, now that's just the top part. Now let's go with the volume of the cylinder. It's a full cylinder. There's some tricks though. We don't know the height. Don't use 13. Okay, the height of the cylinder is only 9. The reason? From here to here, right? If the radius from here to here is 4, the radius from there to there is 4. So the height is going to be 9. The radius is still going to be 4. So go ahead and get what that is. Okay, my calculator is giving me 452.389. All right, and now if I add those together, this is for the cylinder part. All right, so total volume. And do they say round? Nearest cubic meter. I'm getting 5. If I round it, I'm getting 586 cubic meters. Let's make sure all the dimensions, they're all in meters, right? Yeah, so that's good. All right, I'll finish up the last 2 problems from this exam on the next video.